The load disc is a unique reaction washer that fits under a regular nut and stops the bolt from turning. It becomes the reaction point for the torquing tool, and it also allows the tool to lock onto the application hands-free. Its benefits include hands-free operation, even upside down, no bending or side-loading of the bolt, that is straight axial tension, consistent low-friction surfaces for the nut to turn on, no need for a backup wrench to hold the opposing nut, a full range of materials and multiple styles for every application. It works with both square drive or narrow clearance tools. Load discs come in two basic styles: DM for use in gasketed joints or where significant movement will happen as the flanges are compressed, or DW for use in metal-to-metal applications with minimum flange compression. The top has a polished surface against which the nut will turn, so we will want lubrication here. The bottom surface is rough. It fits against the flange because no turning is allowed, and we do not want lubrication here. We do not want the nut to turn on the opposite side of the flange either, against a washer or the flange. No lubrication here. The load disc is used on only one side of the joint. Since it functions as a hardened washer, it should go next to the joint face and no other washer should be used under it. When using the load disc, there are certain surfaces that we want to turn and others that we do not. Using an aerosol cleaner such as a brake cleaner, carburetor cleaner, or ether or acetone-based solvent that will not leave any residual film behind, clean and degrease all the flange faces, studs, nuts, and even the load discs. The only joint component that will receive lubrication is the top or objective nut. In order to control where the lubrication ends up and to prevent oil or grease migrating to surfaces we do not want lubricated, the only type of lubricant we will use is a dry molybdenum disulfide spray lubricant such as Dow Corning Molykote 321, according to the following procedure. Lay out all of the objective nuts, the ones that will be turned on top of the load discs, on a paper or other disposable surface with the bottom or washer side facing upwards. The top side of the nut has the grade or class markings on it, and this should be facing down. Apply a liberal coat of dry moly lubricant to the bottom bearing surface of all the nuts, and then let the lubricant dry for about 5 minutes or until it turns to a dull finish. Turn all of the nuts over so that the top side, with the grade or class markings, is facing up. Apply a liberal coat of the lubricant down inside the threads of the nut so as to coat the bearing flanks of the threads. Again, rotate the nuts bottom side up and give the bearing surfaces a second light coat of moly spray. If possible, let the lubricant dry for 1 to 3 hours before use. If this is absolutely not possible, then ensure that the lubricant is dry to the touch and does not rub off on your finger. No other lubricant should be applied or allowed to contaminate the flanges or the fasteners. Assemble the clean, dry studs and load discs along with the lubricated top nuts such that the stud protrudes about 1 or 2 threads. Take care as the studs go through the flange that they do not pick up any grease from inside the joint that could be carried to the back side of the flange. Then screw on the clean backside nut. Snug the assembly by tightening the back nuts and/or the load discs by hand or with a manual wrench, enough to remove any slack from the joint. The dual socket has 2 sets of splines that engage the drive and the housing of the tool. The inner socket turns the nut and the outer socket holds on to the load disc. There is no need for an external reaction arm. A locking mechanism secures the socket to the nut and the load disc, allowing the operator to work hands-free. Place the dual drive socket over the top nut and the load disc until fully seated. You may have to rotate the inner socket until the 2 pieces align. Attach one or more Avanti tools to the dual splines of the drivers and secure with the drive retainer button. Pump pressure should already have been set, and the tools should otherwise be ready to begin the torquing procedure. As torquing begins, note that the inner socket is turning the nut while the outer socket reacts against the load disc. As with any hydraulic torquing operation, advance the tool until the socket no longer turns at the preset pressure and torque level. To remove the load disc, turn the tool over so that it will drive the nut counterclockwise as the piston advances. Place the tool onto the dual splines of the driver until fully engaged and secure it with the drive retainer button. Pump pressure should already have been set to the maximum, giving the tool its full power. Cycle the tool until the nut moves freely and can be removed by hand. Note, as with any system, it may be advisable to remove the loads on the bolts gradually and in steps in reverse order of their tightening, so as not to misalign the joint or to overload a few remaining studs. Remove the tool and the drive socket. Unscrew the top nut. Remove the load disc by hand. There may be some residual pressure on the load disc which requires a few taps on a spanner wrench to remove it. This residual pressure is evidence of the counter-nut effect that kept the nut and the load disc in place and resisted loosening of the joint. If you compare the used load disc on the left with the new one on the right, you will notice that the threaded insert has been pulled up along with the stud and is no longer flush with the bottom of the nut as in the new load disc. Replace the load disc and repeat the assembly instructions above before reassembling the joint. Do not try to reset the threaded insert. The shorter DW driver attaches to the load disc by means of a sliding lock which engages matching grooves on the outside body of the load disc.